All right. Since this is a 3 degrees of freedom app, in other words, it's a seated player app. The player cannot move around physically except turning the head around. We are going to demonstrate how to use C# script to help the player move around virtually. So we are going to create a C# script, and we are going to name it player. Okay, and we're going to link it to SR rig. So SR rig, add component in the inspector window. Component should be scripts and player. Okay, right now the player file, C# script file is just a template and it's linked to XR rig now. So we are going to write the code into player file. Okay, it's a template file, and there are two functions, start and update. Okay, we don't have to worry about start, but for update. So we are going to put the code here to control the behavior of the player and to let the player move around, or in another word, to change the position of the player as time goes by. Okay, and it works this way. The update function is called constantly or regularly. It's like an infinite loop. For every loop, another frame is presented to the user, okay, and the update function is called once. Okay, and if in every loop we change the position of the player, then the player seems to be moving around in the scene. Okay, and okay, so we are going to define a few global variables. Okay, the public float data type theta. Initial value is 0. It's a floating data type. And another float variable delta. And we define it as a circle, like a 2 pi. Okay, it's 2. Okay, floating number times pi is 3.14 floating number. Okay, and the delta is just about one section of the circle. So we can divide it by 360. Okay, so we divide the circle into 360 sections. Delta is just one section. So we hope that within 1 second, and the angle is changed with the delta. Okay, and yeah, we are trying to let the user, the player, turn around along a circle. Okay, and another variable, call it radius. So the radius of the circle, we can define it as 500 units or meters. It's a floating point number. Okay, yeah, it's a float number. Okay, so we're going to use those 3 variables, and inside update. For every loop, we increase theta value. Okay, theta plus equal, okay, is, let's say, increase by delta, okay, times time dot delta time. Yeah, there's a trick here. If we don't have this times time dot delta time, then for every loop or every frame or every update, theta will be changed. Okay, and for powerful computer, powerful faster devices, this could be looped very quickly. And for slower devices, that could be looped slowly. But if we have this time dot delta time, this inserted, it will adjust it no matter what device you are running on the code. Okay, it will adjust it to every second. The theta will be incremented by delta. Okay, so every second there will be an angle change of 1 piece of 360. Okay, and next we're going to find out the position, new position of XR rig. Okay, call it float x equals to radius times math dot math float cosine theta. Okay, so we get the axis value, okay, and float c or y. Should be c. Okay, you can look at this here, and so y is vertical, so we use x and c for the ground axis. Okay, c equals to radius times math dot sine theta. Okay, so after we get a new position of this XR rig, we can assign it to SR rig. So for every second, we change the position of the XR rig, which has the main camera on it. Okay, that represents the player. Okay, so transform the position equals to the new position vector 3. Okay, and we use this to define new position of x, y, z. Okay, x. Okay, the height of the camera or XR rig is 20. C value C. Okay, and we want to adjust that. It will start, or the circle should be around 500 position. 500 by 500. Okay, and in this way, the player will be within the terrain range. Okay, otherwise the player will be outside of the terrain. Okay, and so that's it. after we have written the code, we save it. Okay, and it's convenient to find out if there's any bug, any error in the code. I run it here, just simulate. So it tries to compile the file and run it here. Okay, without installing build and installing on your iPhone. Okay, if there's no error, then of course we can try to build and run on the iPhone. Okay, save and build and run. So it will convert the project into Xcode. Then from there, build and run, install and run on the iPhone. Okay, just wait for a few moments. Okay, so Xcode is started. Here we can tell that it's not finished yet. Okay, but let's switch to Xcode and get ready. Okay, and my phone is connected to the computer by using the USB keyboard. And but it's not recognized. And click here. And okay, I'm going to build for the iPhone. So switch to iPhone. Can we switch now? No. Let's try again. Okay. So, okay, it's finished converting to Xcode. Let's get to Xcode and build and run. Okay, build. Let's just wait for a few moments. Installing, running. Good. Let's see what we can see using the Google Cardboard. Okay, so this is what we see using the Google Cardboard. Okay, and of course, we're in the Google Cardboard, we see a 3D image, okay, instead of the double vision. Okay, and okay, you can tell that we are circling around the terrain. Okay, and of course we can still turn around. See, left, right. Okay, and down, up. Okay. At the same time, we are moving around virtually, which is controlled by the C# script. So that's it.